Are Navy SEALs equipped with a secret water source on aircraft carriers? How do these massive floating cities produce clean drinking water from the vast expanse of salty seawater? Prepare to be amazed as we unveil the astonishing technology behind how aircraft carriers transform seawater into a lifeline for our elite forces. Can you imagine the ingenious system used to extract pure water from the seemingly endless ocean? Get ready to dive deep into the fascinating world of maritime engineering as we unravel the mystery of how aircraft carriers create fresh drinking water for the Navy SEALs in the most challenging environments imaginable. Stay tuned for a mind-blowing revelation that will leave you thirsty for more answers. Aboard the USS Carl Vinson, an extraordinary initiative is taking place to support Haiti by utilizing the nuclear reactor on the aircraft carrier to produce a crucial resource, water. Situated just 5 miles of the coast of Port-au-Prince, the USS Carl Vinson has begun producing purified water for the devastated country. The process involves harnessing excess heat from the vessel's reactor to evaporate seawater, leaving behind the salt and resulting in pure drinkable water. Captain William McKinley, in charge of the reactor, has emphasized the impeccable quality of the water being produced. The USS Carl Vinson contains 4 distilling facilities, each capable of generating 100,000 gallons of water per day, leading to a cumulative output of 400,000 gallons. Some of the water is set aside for the ship's need, but the extra amount is given to aid relief operations in Haiti, making it a valuable asset for the locals. In the past, carrying safe drinking water presented challenges for ships crossing oceans. For example, the sailing frigate USS Constitution, one of the original 6 frigates built for the United States Navy, had a crew of 450 individuals. Taking into account that humans require nearly a gallon of water per day, as stated by the Mayo Clinic, 8 men carrying a substantial amount of fresh water as cargo. The ingenious utilization of the USS Carl Vinson's nuclear reactor has revolutionized the production of purified water, eliminating the need to transport massive quantities of drinking water for the crew. This innovative approach has relieved the burden and logistical challenges associated with water transportation, ensuring a sustainable and self-sufficient supply of clean water on board the aircraft carrier. Distillation. Aircraft carriers, including those utilized by the Navy SEALs, rely on the distillation process to convert seawater into drinkable water. Distillation involves heating the seawater to produce steam, which is then condensed back into a liquid form. This condensation separates the salts and impurities from the steam, leaving behind clean water. To ensure the quality and safety of the produced water, it undergoes additional treatment, such as filtration, disinfection, and testing. Special distillation systems on aircraft carriers are designed to handle large volumes of seawater and provide a continuous supply of fresh drinking water for the crew. Although distillation is energy intensive, it remains a reliable and effective method for desalinating water on naval vessels, guaranteeing access to clean drinking water during sea deployments. Aircraft carriers, including those utilized by the Navy SEALs, employ the process of reverse osmosis to produce drinking water from seawater. Reverse osmosis utilizes a semi-permeable membrane that allows water molecules to pass through while effectively blocking salt and other impurities. In this method, seawater is pressurized and forced through the membrane, creating a separation between the fresh water and the concentrated salt water. The high pressure applied to the seawater allows only the water molecules to pass through the membrane, while the salts and impurities are left behind, effectively producing fresh water. Reverse osmosis is a prevalent and effective technique for desalination, which ensures a trustworthy supply of fresh water for aircraft carriers. The distillation and reverse osmosis techniques both possess their own strengths and weaknesses. Although distillation is a well-established and dependable technique, its operation demands a larger amount of energy. In general, reverse osmosis tends to be more energy efficient, but it is essential to maintain the membrane properly to preserve its integrity. To provide enough potable water for the Navy SEALs and crew, aircraft carriers typically employ various techniques in combination. Careful examination and refinement methods are employed on the produced water to guarantee that it meets the high standards of quality and is fit for human consumption. Systematic supervision and upkeep are carried out to ensure that a consistent source of pure potable water is available on the vessel at all times. Aircraft carriers, including those used by the Navy, have desalination plants on board. These plants utilize advanced technologies, including nuclear-powered desalination systems, to produce drinking water. The tradition of employing reactor-powered desalination systems for producing drinking water traces back to the USS Nautilus, the pioneering nuclear-powered submarine commissioned over half a century ago. Aircraft carriers do use seawater for various purposes, including desalination. The U.S. Navy uses high-tech nuclear power systems to provide the necessary propulsion for aircraft carriers and other ships and submarines to ensure a reliable source of drinkable water. Each aircraft carrier is equipped with reverse osmosis desalination capabilities. Using this process, these carriers can produce up to 200,000 gallons of fresh water per day. Advanced desalination plants on board employ semi-permeable membranes to effectively remove salt and impurities from the seawater, resulting in high-quality fresh water that meets drinking water standards. As the aircraft carrier sails through the vast ocean, its desalination plants diligently produce thousands of gallons of fresh drinking water each day. The nuclear power engines hum with relentless energy, allowing the carrier to operate without refueling for decades. Their water supply threatened, the crew faces an unforeseen obstacle. Will their training and spirit prevail as they plunge further into the unknown? Their fate hangs in the balance, navigating treacherous seas and daunting trials. Success or failure, the answer remains uncertain.